Our measurements of a bathroom starting at point A. Okay, we're gonna draw a coordinate grid, and we're gonna call this point A. I don't know, that may not be the best choice, but we're gonna call it that just to make our lives easier. Go west for 30 inches. Okay, so let's call this 30 inches. I'm gonna take the inch mark off because we'll just assume they're all inches. All right. Then south for 10 inches. Then west, okay. The following are measurements of a bathroom. Starting at point A, go west for 30, then south for 10, then west, so I'm physically at this spot right here. Then I go another 47 inches, so now I'm at, I guess you could call it negative 77 or negative 30. Because I'm going another, is that right? 47, yep. South for 22 inches. Okay, so now I'm down to negative 32. I'm going to follow these directions here in a second because at the moment it's not making a whole ton of sense, but we'll figure it out here. Okay. Then west for 13 more inches. Okay, so that's going to take me to what, negative 90?
Yeah.
Okay. Then north. Okay, so let's just draw this picture. Okay, so we're going to go here, 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 here. Okay, south for 22, west 13, north 71.5 inches. Who makes drawings like this? This is, so I'm at 32. So that'd be negative 32, and I'm going to go up 71.5. Negative 32 plus 71.5 puts me at 39.5. So somewhere up here at 39.5. East for 90 inches. Okay. Then back to point A. Then back to point A of 45. Now, why are they saying 45? That doesn't make sense. Let me make sure I did that right. You dropped south for 10, south for 22, that's negative 32. Then back north for 71.5. Let me try that. Negative 32 plus 71.5 is 39.5. So when they're saying go back south like this, back to point A, and then they said 45 inches. Well, this side length over here is not 45 inches, it's 39.5 inches. So I'm like, why are they saying 45 inches?
I don't know.
Yeah, I'm a touch lost on why they're saying, it says back to point A. A of 45 inches. Okay, a bathroom closest, I'm going to ignore that piece of information because I think that it's wrong, but a bathroom closet, I'm sorry, a bathroom closet is part of the bathroom, but not included in the above measurements. The closet is 25 by 28 and is accessible from the closet door attached at point A. Okay, 25 by 28. Okay, and it's attached at point A. So that must mean that 25 inches wide. Okay, so this is 25 inches wide by 28 inches deep. So here's your closet. I guess those negatives don't really matter. I was just putting it on a graph.
Sure.
Yeah, they really don't matter. Draw the layout of the bathroom by scale. Well, so this is the approximate. To me, this is what they're describing.
Yeah, that makes sense. Let me see if I can find a similar problem in the textbook and make sure.
Okay.
Because usually I can. I haven't.
I'm sure they do. Finding anything?
Not yet. There's 4 different sections that we're doing.
Well, I guess this is only an 8-week class, so
Yeah.
things kind of move quickly, don't they?
Yeah. Yeah. Oh yeah. It looks like I might be or not.
Found one?
Not yet, but I'm seeing like graphs and stuff now.
Okay.
I'm not seeing anything. I think we'll just roll with what we've got.
Okay. So the first part is just draw the layout by of the bathroom by scale. So I think they just want me to kind of label the sides, so to speak, or I don't know if you need to lay it on a graph, kind of the way I did.
Sure.
I'm not really sure how they want you to do that. The other part B, determine the perimeter. We definitely can do that. So this is, obviously 39.5, and this is 32. This is 25, 28, 5, 10. Oh, wait a sec. This should be easier than that. Oh, this is much easier than that. The perimeter, basically, if you were to take the different lines and extend them out to the edge, Let me be
I'm with
careful about that to make sure I'm suggesting that correctly. So the orange part is going to be 90 times 2 plus 71.5 times 2. But that's not the only part of the perimeter. We do have to figure out the bathroom. The bathroom's got 2 28ths and 1 25. Now, why only 1 25? Because the top part of that blue rectangle is actually attached to the orange wall, and we've already counted it.
We already counted that. Okay.
So
that makes sense.
This is what I'm assuming we're going to have. 90 times 2 plus 71.5 times 2. Plus 2 times 28 plus 25. I ended up with 404.
404?
Yeah, and that would be, now, they want it in square feet. This is in square inches.
Okay. So we have to multiply that by 12?
No, wait a sec. This isn't square inches. This is just plain old inches because this isn't area. This is perimeter. So we would have to change that by dividing by 12, yes. So 404 divided by 12 means we have 33.6 repeating for the number of feet.
Right. Okay.
Now, on the next part, the area, I would divide it into rectangular pieces, okay? Such as we got one piece there, one piece here, one piece here, one piece here. And so we would add up the 4 different area chunks. So, let me get rid of this. Let's see, the one on the far left would be 13 by, now remember, I'm doing this all in square inches, and once I get it into square inches, and then I'm going to convert it into square feet. So 13 by 71.5, oops, 71.5, that's a bad looking one, but oh well, plus 47 times, let's see, 10 plus, that'd be 49 and a half, because you'd have the 10 below the x-axis and the 39 and a half above the x-axis.
Right.
Okay, then I have 30 times 39 and a half. And then, of course, I've got the closet, which is 28 by 25. Oops, not 28 by 28, 28 by 25. So 13 times 71.5 plus 47 times 49.5 plus 30 times 39.5 plus 28 times 25. I got 5,141 square inches. Now, how do you convert this into square feet?
We're not just divided by 12?
Actually, you divide by 12. You're either going to divide by 12 twice, because you have to divide by 12 for the length and the width, or you're going to divide by 12 times 12. Now, 12 times 12 is 144. So I'm either going to take the or 5141 and divide by 144. Does it make sense why I'm dividing by 144?
Yes, because it's inches squared and not
Yes.
inches.
So I'm getting 35.7 square feet.
Okay.
All right. Does that make sense?
I'm with you. I got it.
Sorry for yawning.
No, you're good.
All right. So let's see here. Solve by completing the square. Ooh, completing the square. Well, the first thing I would do is I would take that 8 to the other side.
Okay.
Or I guess I should say the right side. So x squared minus 16x plus blank equals negative 8. You see how I moved that to the other side?
Yes.
Okay. The next thing we want to do is add a value to both sides. Now, I use a fraction when I teach this. I use this fraction right here, b squared over 4a. A lot of Algebra 2 teachers like to do b over 2 quantity squared.
Okay.
Now, is there a difference? Well, there is if the a value, which is out here in front, if the a value is something other than 1. Currently, the a value happens to be 1, so you will not notice a difference between either one of these methods.
Okay.
So, do you have a preference?
I do not. It does not make any difference to me.
Okay. Then I suggest we use the b squared over 4a method in case they change something on you, but
Sure.
I'm going to guess that they probably won't. B squared over 4 times 1. That gives me, 256 over 4, which is 64. So 64 is what we're adding to both sides of the equation. Now, what do we have on the right side?
Negative 8 plus 64.
And what does that add up to?
56.
56. Okay. Now, on this side right here, we're going to factor this.
Okay.
Okay, so what does that factor into? We're looking for something that multiplies together to give you 64, but adds up to negative 16. Obviously, that means both of them are negative.
Sure.
Can you think of things that multiply together to give you 64 but add up to 16?
8.
That's
8
right,
and 2.
8 and 8.
8 and 8.
Now, completing the square means that these two things are going to be the same. They always will be the same. If you've added the right number to both sides, if you've added the correct number, then that means when you go to factor it, you're always going to get something squared.
Okay.
Always. How do you get rid of a square?
Square root.
Square root. So we're going to get x minus 8 equals plus and minus. Now, I don't know, how detailed is your math teacher going to get? Like, for instance, radical 56. Does your math teacher want you to split it up into, let's see, 4 goes into that 14 times? Does your math teacher want you to write 2 radical 14?
I think he'll give a lot of grace, but he would probably prefer if we split it.
Okay, so does that ring a bell on how to do that, or did I go too fast?
Can you run through that one more time?
Okay, so what we're looking for are perfect squares. I call them perfect squares, and then these are what we call leftovers. I'm sorry. I call them leftovers. I don't know what the rest of the world calls them, but I call them leftovers.
Okay.
Okay. I look through my list of perfect squares. 4, 9, 16, 25, 36. These are all perfect squares. And I if I needed to go further, I would. but I'm looking for numbers that go into 56.
Okay.
So they have to be perfect squares. Now, I'm going to tell you a funny story here if I get a chance. At least it's funny to me. I told my students about it today. And so my final answer is going to be 8 plus or minus 2 radical 14. I don't need to do any more with that because unless you want to change them into decimals, which I highly doubt your teacher wants to see.
Sure.
Did that make sense why I split it up into perfect square or why I looked for like a 4 to come out?
Yes. Yeah, I understand that.
Okay. Okay, so here's my, I'll bring that back in a second. Well, do you need to write it down?
No, I got it.
Okay.
I've been writing as
All
we
right.
go.
Okay, so here's the funny story. I teach my students when they're doing the square root of 18, I teach them to break it up into radical 9 and radical 2. So they look for a perfect square to pull out, and then they simplify that. Well, I tell them a little story. The little story is basically that the square root is like prison. Okay? Now, the 2 is a relative or a friend that you are going to visit in prison. Okay? You are the perfect square.
Okay.
Perfect squares cannot be trapped inside a prison, just like an innocent person cannot be trapped inside a prison because legally they've done nothing wrong. You go to visit a friend or family member, you can leave whenever you want. That's exactly what this is the story that I tell my students.
Gotcha.
So Grant's at Leo High School, and his math teacher shares this story. So instead of writing 9 and 2, she writes 3, 3, and 2. And she uses this story. There are 2 twins that have been incarcerated in prison. One of the twins is evil and stronger than the other one, kills the other twin, and then escapes jail, leaving you with 3 radical 2 as your final answer. So I go from me, who's just visiting a friend or family member, to an evil twin that's killing another person. I was like, what the heck's going on here?
It's not an ethics class.
Yes, I thought it was an interesting way to get the kids' attention.
Yeah, I mean, I'm sure that was effective.
I'm sure Grant will never forget it. All right. What's next?
Ready for the next one. Okay.
Okay. So this is called Rationalizing the Denominator. It's not my favorite thing in the whole wide world, but it's what math teachers do, evidently. Okay, so the idea here is to get rid of the I from the bottom. That's my goal. Okay. My goal is to get rid of this from the denominator. In order to do that, we need to multiply by the conjugate of the denominator. Okay, so that term is what we're talking about. The conjugate, and I'll erase that word here in a second, of that would be 3 minus 5i. In other words, you change the sign of the second. The first stays the same, but you change the sign of the second. So we can't use the word opposite because they are not opposites of each other.
Right.
So that's the term conjugate. And whatever you multiply the bottom by, you must also multiply the top by, because you can't multiply by different things to the top and bottom. Otherwise, you would change the value. Now, are you familiar with this term FOIL?
Yes, we talked about that last week.
That's what you're doing. You're doing it not only to the top, but you're also doing it to the bottom. Now, one thing you do have to keep in mind is that I squared equals -1. Do you remember that fact?
Yes.
Okay. So every time we come across an I squared, we can substitute -1 in for it. Now, I'm a boxer. You may not be. But I use a box just to kind of organize my work so that I don't make a mistake.
So we're just foiling the numerator to the numerator and the denominator to the denominator.
Exactly. And just matching things up, and then eventually going to add like terms together. Now down here in this corner, I get 40i squared. So what is that one really?
Negative 40?
That's negative 40. Well, that negative 40 can be added together with the 12. Those two can get added together, and that's going to give me negative 28. Likewise, the negative 20i and the negative 24i give me negative 44i. So there's my numerator. And then I'm going to come down here, and I'm going to do my multiplication. Mind you, you don't have to use boxes if it's not something you want to do. You can just draw the arrows. And I can't remember, is that what you said you like to do?
That's just what I remember learning. And so
Okay.
it doesn't really matter to me, but that's how I learned it forever ago.
Then you can ignore me on this, but you have the general idea of what I'm doing. But 9 plus 25, that's that negative 25 and that I squared cancel out. That gives me a positive 34. Well, guess what? Those two cancel out completely. And my goal of getting no i's in the denominator is true. Now, technically, I could leave my answer like this. I don't know if your teacher wants you to simplify it because basically we could take a 2 out and we could get negative 14 minus 22i. And if I take a 2 out of the bottom, I have 2 times 17. And these two things cancel out. So now some teachers say you can leave your answer like this. And some teachers want you to separate it into something that looks like this. They refer to this as A plus BI form.
Okay.
So I don't know which your teacher would prefer, but I mean, I guarantee that the math teacher will probably want one of these two.
Sure. I'll go the extra steps just to make sure.
Yeah, I understand.
Because I don't know what he wants. Are you talking right now?
No, I'm not. Sorry.
Okay.
I didn't know if you were still
okay.
writing stuff down because I went kind of fast. I didn't know if you needed
Nope,
time.
I got it.
Okay.
I was tracking with you.
All right. Cool. All right, solve that. We want the radical by itself, so we got 6 minus x, and we're going to take that 5 and move it to the other side by subtracting 5, giving me 3. So this is going to be a lot easier than some of those other questions. We're going to square both sides, giving us 6 minus x equals 9. And then, of course, we can subtract 6. Negative x equals 3 and divide by negative 1, so x equals negative 3.
Okay. Let me
Now,
this time.
Yeah, they want me to solve this by any method. Could I use completing the square? Probably. Do I want to? No. I'm going to use the quadratic formula. Now, it might even be factorable. Like if I put 8x squared minus 2x plus 10 equals 0, that might be a factorable item. But I could continue to guess and check until I get the factors. Or
Sure.
I like to do my quadratic formula in 2 steps. So the first step that I like to do, and maybe I should explain what I'm doing, but the first thing I like to do is the b squared minus 4ac part. In this case, that would be negative 2 squared minus 4 times 8 times 10. So I would get 4 minus 320. Okay, so that would be negative 316. I do not think that is a perfect square. Plus it's imaginary, so let's see here. 316 square root answer. Yeah, that's definitely not nice. Did I do that right? Yeah, I think I did. Okay. Step 2 is when the opposite of b, plus or minus the square root of, that's where this number, negative 316, drops under the radical.
Gotcha.
Does that look kind of familiar?
Yes.
Okay.
Yep, I remember quadratic formula stuff.
I try to separate the discriminant from the rest of it until I get that discriminant value, because I see too many kids who mess up the discriminant because they're trying to do everything at the same time, and I'm like, just do the discriminant first and then plug it in. So we've got 2 over 16 plus or minus, now the square root of 316. First of all, the negative is going to come out, so that's definitely I, but we got to think about some of these perfect squares, like 4, 9, 16, 25, 36. So I'm just going to try 316 divided by 36. No way. 316 divided by 16. Nope, but we're getting warm. 316 divided by 4. Yes, and it's 79 times. So truthfully, I'm going to take this thing and I'm going to break it up into the square root of negative 4 and the square root of 79. Well, what is the square root of negative 4?
Negative 2?
Close. It is 2i. 2i. So the square root of 4 is obviously the 2 portion. You're basically doing something like this. Square root 4, square root negative 1. And that's where you get your 2 and your I from.
Gotcha.
Now, can you reduce this? What about 2 into 16? How many times does 2 go into 16?
8.
It goes in, yes. So we can reduce this to 1/8 plus and minus I radical 79. Whoa, I'm really close to the edge. All over 8. There's your final answer in the bottom right corner.
Okay. Give me a second to write that one down.
Yep, no problem. Tell me when.
Usually I'll write as you're talking. This time I was just watching.
That's okay.
I'm a little.
Some things are easier to follow and write down than others.
Right.
You caught up? Or are you still writing?
Not quite.
Okay.
I'm still writing.
No, you're fine. You're fine.
Use that yelling. Was that Nate or Grant?
Nope, that was. I'm still at Homestead, so there's boys out in the hallway. They're doing track practice out in the hallway.
Gotcha. I think I got it.
All right.
So that is the 2 assignments that I have on my computer.
Okay.
Those 2 that we just did. And so if you want, I can email you.
Yeah.
I can scan it.
Just take a quick picture with your phone.
Okay.
And then just Do you have, can you email from your phone?
Yeah. Yep.
Okay. My email address is teachthemlive@gmail.com. Well, right there. So,
Okay.
if you get the picture taken, you can send. All right, now, are you allowed to use a graph? Well, no, that's probably not a good idea. Okay, I do see a way to factor question, well, 14. Yeah, I do see a way to factor it. Do you want to use factoring to start with? Well, actually, factoring would get you all the answers. Okay, so I'm breaking this into two different groups, even though everything's on the same side.
Sure.
Can you tell me what the greatest common factor is inside the first box? What do they both have in common?
1, or excuse me, hold on. There's 2 X's.
Right, that's what they have. You're exactly right. What about this one? What about the second box? What do they have in common?
3.
Okay, now, so in the first box, I'm going to take out an x squared, which would leave me x plus 2.
Okay.
From the second box, I'm going to pull out a 3, which would leave me x plus 2. You see how I did that?
Yes, I'm with you.
Okay, now, suppose we look at these two green boxes. What do these two green boxes have in common? Okay,
Go ahead. It's x plus 2, right?
They both have an x plus 2. So in other words, I'm going to take an x plus 2 out of this first one, and I'm going to take an x plus 2 out of the second one. Well, if you take an x plus 2 out of the first one, what are you left with?
X squared.
X squared. If you take an x plus 2 out of the second one, what are you left with?
3.
So you just factored it.
Gotcha.
Okay, now how do I find the answers now that I have it factored? Set the factors equal to 0, and you solve each one of them.
Gotcha.
Okay, so what's the first one?
X equals -2.
Okay, and then on the second one, when you subtract 3 to the other side, you get x squared equals -3. And then, of course, you're going to take the square root of both sides. So what do you end up with?
X squared equals the square root of, or I square root -3.
Okay.
Or excuse me, I square root 3.
Yeah, you're getting warm. There is a plus and minus in front. Okay, because when you take a square root in a solving situation, you must account for the fact that you could have a positive or negative solution. But you are correct, the I comes out of the radical and nothing else does. So I have 3 answers to this question. This one is a real solution, and these are imaginary values, or they might say complex.
Gotcha. Okay.
All right, does that kind of make sense?
Yes, that makes sense.
Okay.
This is super helpful.
Good. All right, pick another one.
Let's do 37.
37, okay. So looks like I want to move that 4 to the other side. So the square root of x minus 10 equals 4. Now you tell me what to do. How do I get rid? Now that I have the radical by itself, what am I going to do to get rid of it?
Do we need to...
What's the opposite of taking the square root?
Square it?
Square both sides.
Gotcha.
Now notice in this situation, I didn't have a plus and a minus. The difference is I was not taking a square root. I was getting rid of a square root. In that last example, when we were taking a square root, we ended up with the plus and minus.
I see.
But here, the only the only thing you get is 16, and then of course you add
10 to it.
Yep, to get it to move to the other side. And so x is equal to 26.
That one was easier.
Yeah, that one's way easier. There's no factoring necessary.
Right.
Okay, what's next? Which one?
42.
42, okay. We'll have to
Doing both 42 and 44 are the next two on the homework.
Okay, 42 and 44. Okay, so remember the idea of getting the radical by itself?
Yes.
So I'm going to move that x to the other side, and I'm going to have radical 31 minus 9x equals 5 minus x. Okay, so how do we get rid of the radical?
Square it.
Square it. Square both sides, right? So the radical
Yes.
and the so they cancel out. 31 minus 9x. What happens on the other side?
Is it possible to? I guess I don't know.
When you say that you're squaring something, aren't you multiplying it times itself?
Right.
So
would it turn into 25 minus x squared? Is that what it turns into?
you're getting
foiling?
warmer.
Okay.
There is a 25 and there is an x squared, but what about the insides and the outsides? See,
You're right.
You did the first and the last, but you forgot the insides and outsides, so you would have to do those as well, and that would be negative 5x and negative 5x, which really would be negative 10x. Now what should I do? What do you think? What do you think I'm trying to indicate with those two arrows?
We need to get the x on the same side, right?
We need to get everything on the same side. Now, the reason we have to get everything on the same side is because we are dealing with a quadratic. And since that quadratic also has a linear term, we have to push everything over, and we're either going to factor it, we're going to use completing the square, or we're going to do the quadratic formula, whichever one makes more sense, whichever one's easier.
Sure.
I think factoring might work this time, but we'll see. Now, I'm going to put that x squared term first because we're used to seeing our exponents in decreasing order. If I add 9x to the other side, add the 9x here, I'm going to get negative 1x. And if I subtract the 31 to the other side, I would get a minus 6. This is a nice factorable question. What things multiply together to give me negative 6? Obviously, that must mean one is positive and one is negative. They have to multiply together to give me negative 6, but they have to add up to negative 1.
It'd be positive 2 and negative 3.
Perfect. Remember, now we need to set the factors equal to 0 and solve them. It won't be that hard to solve. We should get negative 2 and positive 3.
Perfect.
You got
So
that?
how do you?
Go ahead.
Yeah.
Go ahead and ask.
How do you decide when to factor and when to use the quadratic formula?
Well, guess what? The quadratic formula is a giant hammer. Okay?
Sure.
If you want to hit a quadratic with the quadratic formula every single time, you can, because it's always going to work. Always. Now, the only reason I chose to factor that one was because it was nice and easy. But
easier.
If you got to the point where you were like, I know how to use the quadratic formula, it's comfortable to me, then you go down there where, to this right here, and you're like, okay, well, let's see here, I can do that. B squared minus 4 times A times C, which is negative 6. Okay, that's it's 1 plus 24. That's 25. Okay, there's my discriminant. X equals the opposite of b plus or minus the square root of 25 all over 2 times 1, which is 2. Okay, so that's 1 plus or minus 5 all over 2. 1 plus 5 is 6, so I'd have 6 over 2 is one of the answers, which is 3. And the other answer is negative 4 over 2, which is negative 2. If you want to use the quadratic formula, it works every time.
Gotcha. Okay.
So I'm serious, if you feel comfortable with quadratic formula and you're dealing with a quadratic, go ahead and use it. And if you're like, man, I don't remember factoring and I don't want to worry about it right now, that's fine. I understand.
Sure.
Because
I just wasn't sure what the thought process was.
Just because the numbers were smaller.
Sure.
That's the only reason. I mean, when they start throwing in, the A value here is a 1. If the A value was like, let's say it was 7, I wouldn't even mess around with factoring. I'd be like, skip it. Let's go to the quadratic formula.
Sure, that makes sense. I'm with you now.
But you can factor. And you know what? Some things don't factor. So you could sit there spinning your wheels thinking, oh, man, I should try to factor this. Well, sometimes they don't factor, and you're just wasting your time.
Right.
And you might as well have gone straight to the quadratic formula. Like the one we did where it was like, I radical 79. Okay? First of all, you were going to get an imaginary number. There wasn't any way for you to factor that whatsoever.
Sure.
So you had to go with the quadratic formula.
Right.
Now, I will tell you this, if the discriminant is a perfect square, okay? If the discriminant is a perfect square, then we can factor it. But if you've already gone to the trouble to find the discriminant, you're halfway to finishing the quadratic formula.
Right.
So I understand you can test it, and we make kids in Algebra 2 do that, but if you're halfway to finding the discriminant, you might as well just keep going.
That's fair. That makes sense.
Okay, so 44.
Actually, I got that wrong. Next one's actually 43, not 44.
43, okay.
My bad.
All right, 43. Nice thing about 43 is there's radicals on both sides already, so we can square both sides. And what happens?
It's just x plus 1 equals 3x plus 1.
That's a lot easier, isn't it?
Yes, it is.
Hey, the ones disappear. I can subtract the x to the other side. And I can divide by 2. What do you get for x?
What is 0 over 2?
0 divided by anything is still 0.
Oh, easy enough.
A lot of kids would have said undefined, and I think, maybe in your mind, your mind was making you question whether it was an undefined answer, but that's only if you have a number divided by 0.
Okay.
And a lot of kids will get to this step right here and say, "Oh, hey, there's no answer to that."
Sure.
Well, and that actually is. It's 0 itself.
I see. I'm with you.
Okay. What's next?
So that was all of the ones for section 1.6. And so I'll jump to 1.7 if we've still got enough time.
We started a little late, so let's do this.
Okay.
Let's see here. Is this 162 or?
Yes, that's also 1.6. So
okay,
you don't
let me
have
jump to the other one.
I'll have to take new pictures for you, I think.
Oh, okay. Gotcha.
I'm not sure how much of this we'll have time to get to.
But we'll look at a few here and see what we can do. Is that your dad?
Uh,
I'm just kidding.
Probably my mom, but
No,
it's my dog
I
barking.
was just kidding. I know it's your dog.
Well, the garage door went up, and
Oh,
that's why.
gotcha.
That's what I thought you were asking.
Okay. No, I was just teasing.
The pictures should be on their way.
Okay, good. Let me refresh and see if it pops up.
It says it as sent.
Okay. There we go.
There it is.
Okay. What do you want to know on the first one?
So we are.
Did you say 3?
No, sorry. Let's start with question 17.
It's question 17. All right. So what do they want me to do? Match the inequality with its graph. Okay. Question 17. We want to graph everything between -3 and 4, but not -3, but we want to include +4. Okay? That's going to be this graph right here, letter E. A parenthesis means to not include.
Okay.
A bracket means we include it.
Okay.
And when we see the equal to means include, but this one does not have an equal to, so it's not including.
I'm with you. That makes sense.
Okay. So, was there another one inside there in that little graphing section that they wanted you to do?
No. Next one is question 38. So do I just
Next one's which?
question 38.
38. Okay. Solve the inequality. 38. You solve this exactly the same way you would solve an equality, right? Something that has an equal sign only. So
Okay.
when you think about moving the 6x over by subtracting 6x and subtracting a 2 to the other side, you would get -6 on this side and less than or equal to and a positive 2x. And then you would divide by 2 and you get a -3 and a less than or equal to x. Now, most people don't write it like that. Most people write it with the x on the left side.
In which case, we would have flipped the sign.
Correct. There you go. So it's treated the same way. You just have to look at how you write your final answer.
Sure.
And then sketch the graph on the number line. Okay, so we've got 0 here. We got -3 over here. So how would you sketch this? Would you use a bracket or a parenthesis on -3?
We'd use a bracket.
Yes, you would. A bracket. Which way should we be drawing the arrow? To the right or the left?
X is greater than. We would go right.
To the right. So what they always told me is that the symbol points in the direction of the arrow.
That makes sense.
But that is
assuming that X is on the left side.
Exactly. Thank you very much. Yep. So that's as hard as that one gets. Okay. What's next?
Next one is 44.
44. Okay, so I'm going to distribute the 3/4. That's kind of ugly, but I'm going to do it anyway. So 9x minus 1 is, less than 3/4 times 16x. That would be 12x. And 3/4 times -2 would be -1.5. And from there, it's going to look very similar to what we did before. Subtracting the 9x, adding the 1.5. So we get 0.5 is less than 3x, and we can divide by 3. So this is going to give us x and 0.5 divided by 3. I don't know what that is. 0.16 repeating. 0.16 repeating. and then I can flip that around. I don't know if data. I mean, as long as he doesn't care whether it's decimals or fractions, do you think he
I'm sure he doesn't care as long as we can graph it.
Okay.
He seems to be pretty forgiving with the homework, at least.
I mean, the only other thing I could say here is that's 1/6, which is the same fraction. So you could say x is greater than 1/6, but if you can just leave it as a decimal, find your 0, you got 1 here, 0.16, somewhere right in there, and you want greater than that, so you'd have this stuff all shaded to the right.
Shouldn't it be a parentheses instead of a bracket?
Ooh, look at the guy catch me in my own mistake.
I thought it was a test.
No, but kids always ask me, when am I ever going to use this in my life? And I tell them the same answer, which is this. What you should really pick up from any math class is paying attention to details and catching mistakes. Because if you can pay attention to I said every job in America, you have to pay attention to details. And if you can find mistakes, not only your own mistakes, but if you can find your coworkers' mistakes, then you will save your company a lot of money because you caught the mistake before it became a big problem.
Right.
So that's what I tell them all the time in my math class that they should pay attention to. That's the important part of what we do. Not that you're going to have to do inequalities the rest of your life.
Right.
But what you just did for me is exactly what I want you to do the rest of your life, is catch mistakes.
That makes sense.
Okay, is there anything major that we're missing, like on the next page? Let's take a look at it just to see. Come on, where are we at here? Something that's like dramatically different.
So the next ones, we're supposed to do 65, 66, and 67, which I assume are all in the same section. They are. And then there's one at the end, 126. That one will probably be pretty challenging just because it's at the end of.
Now, these right here are absolute value equations or inequalities. I will 65. When you have the absolute value bars isolated. Now, if you look down here at 71, the absolute value bars are not isolated, so step number 1 for number 71 would be to divide by 2. But if the absolute value bars are by themselves, then we're going to split this into 2 different inequalities. One of them is going to look exactly like the original one. The other one flips the sign because the right side is negative. So because that right side is a negative, that changes the sign.
I see.
Okay? Now, I'm going to write 2 phrases on screen that are my dumb ways to try to remember things.
Okay.
So, hopefully you see how I misspelled the word "than."
I sure did.
Okay, so that's not the situation we're in. We started off with a greater than sign. The greater than sign, my fancy way to misspell this word, is so that you can see that we're looking for the or. Now, the or typically means that you're going to be graphing 2 things that go out away from each other. The and means you're going to be coming at each other.
I see.
So you're going to be looking for things that are shaded, or maybe you've got 2 brackets and it's everything in between. Or maybe you got 2 brackets and they're going away from each other. But the less than symbol will cause you to go in towards each other, and the greater than symbol will go away from each other.
I see.
But these are solved exactly the same way that you would solve any of these others, like subtract 3. Divide by -4. Oh, by the way, when you divide by a negative number, what happens to the sign?
It goes away as long as you're dividing.
It
flips.
flips.
Okay. I'm
Okay,
with you.
that's an important detail that,
Wrong sign.
yeah. No, you don't have to apologize. It's okay. Subtract 3 on both sides. We got -4x is less than or equal to -12. Divide by -4. X is greater than or equal to 3 because the sign flips. So on a number line situation, oops, get rid of that. On a number line scenario where we've got, let's see, -1, so 0. We've got 3 and -3. We would probably have a bracket with an arrow going out because that's greater than or equal to 3. And at -1.5 with a bracket going that way. Now, if the equal to's are not there, then obviously those are parentheses. But you already know that because you've corrected me the last time. But, so I did want to show you one of those because it does kind of split like that.
Sure.
So what was the other one? 65 and then what?
65, 66, and 67 are all the ones clumped together.
Okay,
And
so
then-
66 will go together because it's a less than sign, but those will be parentheses. 67 will be going out and they're brackets, so it's going to look like this same graph you got here.
Okay.
But yeah, you just have to split it up.
Okay.
And then what was the other one that was a long one? It was on 120.
So it looks like it's a story problem.
Okay, well, I don't know if it's going to be easy or hard. 120. Ooh, it's not even on this page. 126, you said?
Yeah. Oh, did I miss that one? Did I not send you a picture
You
of that?
did miss that one, so I can't even look at it. Now, do you think that story problem might show up on a quiz? Hello? Did I lose you? Are you there?
No, I'm good.
Okay.
I'm here.
You know, you're cutting in a little bit.
Okay.
So do you think that 126 is something you're going to have to...
No, I doubt it.
Okay.
I can send it.
But, yep, there it is. Capital RTVJQ2.
Got it.
But that's the code, and it'll get you in, okay?
Awesome. Thanks so much, Junior.